In this lecture, we're going to derive a new integration technique, something called integration by parts. And this particular method, it isn't so much a procedure, it's really a formula. And to get to that formula, I'm going to start with this formula here, which hopefully, if you look closely, is familiar to you. This is just a product rule. On the left side, I have the derivative of two functions of x, and that's equal to the derivative of the first times the second plus the first time the derivative of the second. It's just a product rule. So what I'm going to do, I'm going to start by integrating both sides of this thing with respect to x. Now the left-hand side simplifies really nicely. The integral of the derivative of an expression is just that expression. That's the fundamental theorem of calculus. And on the right-hand side, I'm going to split this up. I'm going to make this the integral of u prime of x v of x. Actually, let me rearrange that. Let's make this v of x u prime of x dx plus the integral of u of x v prime of x dx. All right, so now I'm going to take this formula. Remember, we're looking for a formula for an integral, right? So what I'm going to do is I'm going to take this formula here, and I'm going to solve it for this expression, for the far right-hand integral, by subtracting this integral from both sides. And if I do that, this becomes the integral u of x v prime of x dx equals u of x v of x minus the integral v of x u prime of x dx. Now, fundamentally, that's it, but we can clean this up some. Right? Take a look at this part here first. V prime of x is dv dx. Yeah, so if I multiply both sides of this by dx, we get v prime of x dx equals dv. All right, so let's substitute that into here. This is the integral u of x dv equals u of x v of x minus, and now I'm going to do it here again. I'm going to do the same thing with this part. U prime of x is du dx, which means u prime of x dx is equal to du. So I'll make that substitution as well. This is the integral v of x du. Right, and that's my formula. Right, that really is my formula right there. Although the way this is usually written, because everything here is a function of x, that of x that we've got at the end of every one of these things just makes it a little cluttered. So this would usually be written, the integral u dv is equal to uv minus the integral of v du. And it's understood that u and v are functions of x. And this is it. Right? This is our formula here that kind of goes by the name integration by parts. So at this point, it wouldn't be unreasonable for you to look at this and say, well, how does this really help me? All I've really done is I've taken one integral and traded it for another integral. And okay, there is some truth to that. But if you think back to what we did with integration by substitution, that's all we were doing there as well. We took an integral that we really weren't sure what it was, and we came up with a substitution that transformed it into another integral where we didn't know what it was. And our goal is going to be the same here. Right? Our goal is going to be to look at the original integral and pick parts to be u and parts to be dv in such a way that this integral is something we know, right? And then we'll just plug u and v, our choices, in over here, evaluate that right-hand integral, and we'll end up with the left-hand integral. That's the one we were really trying to find. Right? So that's going to be our goal in the next several lectures. We're going to look at some specific examples of integrals of functions that can be integrated using this new method.